Hi, this is Jacob Nash with JNGL, and this is the new unit, Unit 5, and this unit is just all about transformations that you might have learned kind of in like 7th grade, but this is about translations, and you'll find out what that means. So what is a translation? Translation is a type of transformation in which a geometric figure changes position, but not... Okay, that's not supposed to happen. But not shape or size. So it kind of slides. So it's sort of like you have a triangle, then it moves, and then maybe it goes up there. But it's not rotating, it's not reflecting, it's not getting bigger or smaller, it's not changing to a different shape, it's just the same. So what is a rigid... Is it a rigid motion, which is the pre-image and the image going to be congruent? Well, if it's not changing shape or size, then yes, it will be a rigid motion. I'm going to ask this question for all 4 different transformations in this unit, and you'll see what it is. So, different directions are what are the ones that are negative motions? If you go left, that makes the x negative. Or if you go down, that makes the y negative. And then for positive, if you go right, that makes the x positive. And if you go up, that makes the y positive. That's probably stuff you already know, but in case you don't, that's what it is. So x is positive because it's moving to the right, and then y is negative. You can see that negative because it's moving down. Okay. All right, here's notations, which is how you can probably say the word like you're like, okay, the transformation, it moved down 5, it moved to the right 3. Okay, good, but how do you put that into an equation? Here's different ways that you can do it, that you might be asked to do. So, we are using some Greek letters that are theta. That looks like a O that's kind of like chopped in half, and then a mu that kind of looks like a backwards lowercase u, and it's called mu. And those are used in this equation just as variables. Like, I could have used A or B, I could use any normal alphabet or any Greek alphabet letters, but I used theta and mu, but you just can't use x and y because they're already used in different things. So, function notation, that's the first kind. You have a capital T, stands for translation, and then you have these 2 things that are called vectors, that if you're trying to type that on a keyboard, it is beside the M, and it is they kind of look like this. There are 2 keys, and they have that, and then a period and or a comma, and yeah, that's what that looks like on the keyboard. But anyways, inside that you put the 2 values that are the transformation, the transformation, but it is a translation. So theta will be the x translation. Theta would represent how much to the right or how much to the left will it be changed. And then the mu is the y translation, how much up or how much down will it go. So that's just how you do that. So if you were moving right 3 and down 5, you would say 3, you plug that in for theta, and then negative 5 for down 5. And then coordinate notation may be the one that you kind of already know. You put in the coordinates that you know. So let's say a certain point that you're trying to translate is 1, 2. Then you do this. This is really how you can put it in. You put in x, and then for theta is going to be how much it changes by the x or y. And I think there's an error in here. Let me look at the notes I have just to make sure, but I'm pretty sure something is not right there. Yes. Okay, that's not right. For these, actually, it's plus or minus. depending on what theta is, you might add or subtract. So anyways, but let's say theta was -2 and mu is -2, I guess. So we put in the 2 from right there, and then -2 right there, and then that is what that would be. So that's called coordinate notation. Vector notation is the same thing as function, but you just don't have the t. Okay. Now here's an example. Describe the translation using function notation. So the one that has the t. So, well, first of all, we can just connect these two things. So prime, when it has this little apostrophe thing, that means prime. That means what happened to the letter after it was translated, or reflected or dilated or anything. So let's connect the points. So F to F prime, E to E prime, D to D prime. Well, there's no point in really doing that, but other than that, it kind of makes it look like a 3D figure, so that's something you might have to do. But really, what we're going to do right now is describe the function. So they're all moving by the same way, because think about it. If it's like this, they all have to move by the same way, because if they didn't, it might end up like this. And there you go. This side got stretched out more, so that wouldn't even be the right thing. So we can just use one of the points, and we'll know that it works for all of them. So we go right 1, 2, 3, 4, down 1, 2, 3, 4, 5, 6, 7, 8. So 4, which this will be positive because we're going right, and that's positive motion, and then down 8, which will be negative. So translation, T, and then we do this. It's going to be 4, that's plugged in for the theta, and then for the mu, it will be the -8. There you go. That is exactly how you can do that. That is what you have to do. You might be asked to translate something, so let's just do a quick example. This is this is 0.51. So 5-1. If you're asked to translate it using this, then you would just go to the right 1, 2, 3, 4, then down 8. 1, 2, 3, 4, 5, 6, 7, 8. So let's say this was called point W, then this one would be named W prime because it's the new one. So there you go. That's how you do things like that. That's how you use translations. Thanks for watching.